Seacoast Mushrooms is a Connecticut-based farm founded by Chris Pacheco that specializes in cultivating a variety of gourmet mushrooms. Growing these mushrooms comes with many challenges, one of the most significant being contamination. Seacoast uses millet as a solid medium to hold the spawn, and the spawn from one millet bag is poured evenly by an operator into multiple nutrient-dense substrate bags of compact sawdust. The pouring process must occur in a completely sterile environment to reduce biological contamination. Our project was to build a system that replicates the operator's actions, opening both bags and pouring desired dosage, as to ultimately remove the risk of microbe contamination and reducing variability from hand pouring the bags.
The bag preparation module is responsible for positioning, weighing, and opening the nutrient-dense substrate bags. The bag is fed in from one side and then rests atop a food scale. The initial weight of the bag is recorded and used later. The nutrient bag is a flimsy plastic that's somewhat organic in shape, and so the module utilizes vacuum cups that are capable of deforming and compressing into the plastic bag. The cups are attached to both a linear and rotational arm. The rotational arm presses into the side of the nutrient bag, and then once the vacuums get a hold of the flap, it peels the bag upright so that the linear arm can then affix to the opposite side of the bag and pull back to create an opening.
The flow control module is stationary in the superstructure, resting above the bag preparation module. It is designed so that an operator can easily place one spawn bag within the hopper, such that one corner of the bag hangs below the open flaps. Upon placement, the operator will step away from the system to start it up and minimize contamination risk. First, two heavy-duty linear actuators crimp one of the bag's corners. Then, a tensioned nichrome wire is heated with current and a stepper motor drives it through the corner of the bag. The heated hot wire is the only instance of the machinery directly contacting the spawn, which maintains sterility. Once the bag preparation module opens the substrate bag, a control loop begins in which the flaps regulate the flow of spawn by massaging the outside of the spawn bag. The change in weight is calculated within a control loop from the aforementioned scale, and new substrate bags are cycled underneath the spawn bag as they are filled to the desired amount.
This module also includes a planar 2-bar linkage with a high torque stepper motor that acts as an agitator. If the scale doesn't sense any change in the weight when the flaps are open, the system interprets that as indicating that the spawn has clumped and bridged over the opening. That triggers the agitator system, which collapses the volume near the opening to break up any major clumps. This prototype has achieved a dosing accuracy of plus or minus 5 grams. This reduces the variance from a human operator by about half.